1, 2, 3. Hey guys, it's Mr. Sanchez coming at you with another lesson. This video is going to be broken up into part 1 and 2. So today we're doing part 1, and that has to do with the graphs, okay? It'll be pretty easy. We're doing section 5.3, exponential functions. We're breaking up the video into smaller parts so that it's easier to digest, okay? Here are the learning objectives. Today we're gonna be focusing on these two, and in the next video you're gonna focus on solving equations. Okay, so graph exponential functions, define the number e. Okay, make sure you write this stuff down. I just have PowerPoint, so it makes it easier for my thoughts to go through, and it's not just my ugly writing anymore. All right, next slide. We're gonna skip this. We're gonna use this later. And basically definitions, you're going to want to write this down. An exponential function is a function of the form f of x equals c times a to the x. Here is an example of what it looks like, where this number a is the base, right? And c is the initial value, right? So I hear the base is 3. And 2 is the initial value. We'll go into what that 2 means maybe later on in class. All right, we're just gonna go straight into an example. We wanna make this video as short as possible so that you can get more information in less time, okay? But not too fast. All right, so first things first, I'm just gonna go over how to graph a function. It's very straightforward. We're gonna draw a table just to give you the general idea. But basically you have f of x equals 2 to the x. We're just going to draw an XY table right here. And let me straighten this out. Right, so we have an XY table, and we're going to include -2, -1, 0, 1, and 2. Those are the points we usually like to use. And then what are you going to do to find out what -2 is? You're going to write 2 to the -2. If you don't know what that is, that's 1 over 2 to the power of 2, which is 1/4. And then 2 to the -1 is 1/2. 2 to the 0 is equal to 1. Anything to the power of 0 is 1. 2 to the power of 1 is just 2. And then 2 to the power of 2 is 4. Right, so we have our x and y values, and we're just going to go ahead and plot these. Okay. So our graph is going to go look like this. 1, 2, 3, 4. 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, guys. So in most of our graphs, exponential function, no, not exponential, that's what we're doing. In quadratics, cubics, we usually start at the origin and, right here. But that's not the case for these graphs. For these graphs, we're going to start at 0, 1, okay? And then at 1, you're always going to have the base. 1, 2 is always going to be there. So that's the base. And then similarly, you're going to have the point 0, 1, and you're going to have 1 over the base at -1. -1, you're going to have 1 over the base. So that'll be 1/2. And that's how you draw the graph. And it's going to grow faster and faster. And you want to be more accurate, at 2, we have 4. Right here. And you're going to see this graph goes like this. Right? One thing you're going to want to know is that we actually have a horizontal asymptote here. So I have a horizontal asymptote at y equals 0. All right. And that's basically how you graph it using a table. All right. Pretty straightforward. And that's just the base functions. We're going to go over how to graph more complicated ones in a bit. Okay. Next up, I want you guys to write down these properties. I'm going to take a moment and pause. The properties of exponential functions are that the domain is always all real numbers. There are no x-intercepts, but the y-intercept is usually 1. The x-axis, aka y equals 0, is a horizontal asymptote, and the graph is increasing and 1 to 1 for the whole time. Another thing is the graph contains the point 0, 1, 1a, and -1 over 1 over a, and the graph is smooth and continuous with no corners or gaps, so a smooth line. Right, so you're always going to have 0 over 1, 1 over a, 1a, and -1 over 1 over a. You're going to draw this example, and this is going to be like our parent function, where if I give you 5 to the x, then this a would be 5 and it'll be 1/5, like 1/5, okay? And that's basically how we do the parent function, the exponential function, okay? And we're gonna draw another graph. All right, so now we have this, we're gonna graph this exponential function. Once again, we're gonna do it drawing a table, but I'm gonna show you guys an easier way to do this, okay? So you're gonna do it drawing a table. It's gonna make our lives slightly easier. You have -2, -1, 0, 1, and 2. When you plug it in, 1/2, so you're gonna have 1/2 to the power of -2, that becomes 4. 1/2 to the power of -1, that becomes 2. 1/2 to the power of 0 becomes 1. 1/2 to the power of 1 is 1/2. And then 1/2 to the power of 2 is 1/4. All right, if you don't believe me, try writing it in a calculator and it'll make sense, okay? And then all you gotta do is draw this graph right here, like this. And one thing you're gonna notice is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Once again, 0, 1 is here, right? At this point right here. So we always start here. And then this time, you're gonna have -1 too. So at -1, you're gonna be 2. And then at -2, you're gonna have 4. And then at 1, you're gonna have 1/2. And then this time our graph is gonna look more like this. Okay, like this. I'm sorry, the iPad autocorrected, but it should look more like this. And once again, you're gonna have that horizontal asymptote, y = 0. One of the things that you notice is this looks like the y to the -2, 2 to the y = 2 to the x graph, only if you flipped it on the x-axis. And we'll go over what I mean by that in a bit. And that's the graph, all right? Pretty straightforward. If you look at this slide, it kind of explains in detail what happens. So originally we drew y = 2 to the x. And then what you'll notice is if you 2 to the if you were to do the -x, so we graph y = 1/2x to the x, right? So you can rewrite this 1/2 is the same thing as 2 to the -1. And using the powers of x, the rules of exponents, 2 to the -1 to the power of x becomes 2 to the -x, right? So this is this. And this is a reflection about the y-axis, right? So instead of having to remember how to do it, you just do a reflection across the y-axis. And it's going to become decreasing instead. Well, you'll have time in class to practice it, so don't worry if you don't get this too much, okay? And then these are the properties I want you guys to write down. The properties is the domain is all real numbers or -∞ to infinity. There is no x-intercept. There's only a y-intercept at 1. X equals y = 0, the horizontal asymptote. It's decreasing and is 1 to 1. The graph contains the following points, and the graph is moving continuous. And this graph, I want you guys to write this all down. One thing you notice when it's to a when the base is a fraction less than 1, between 0 and 1, it's gonna be decreasing. Okay, that's basically it. So you basically just flip it. And you might think that these points are the same as the last one, but when you have -1 comma, let's say 1/1/2, that becomes -1 comma 2. So it just flips and it works out. All right, we're gonna graph one more example and we're gonna be done for today, okay? I'm gonna show you guys how to do this using 3 graphs. We're gonna do this in step by step, but our goal is to be able to graph this by ourselves, doing it one transformation at a time. Okay, so we need 3 graphs. And then that'll be it for this video. Okay. All right, so we're gonna start out. We're gonna start out with this. We're gonna start out by graphing y = 2 to the x, okay? What you're gonna do is you're gonna start at 0, 0, 1 comma 2 and 1 over 1/2. We know it looks like this. Oops, it should look like this, right? Next, what you got to do is you want to reflect it. Okay, now you're going to do y equals 2 to the negative x. We know what that looks like. We're going to reflect this across the x-axis. We still cross 0 to 1, but this point's going to go to the other side. So this goes here and this goes here. And our graph is now going to look like this. Okay. And last but not least, since the -3 is on the outside, you're going to go down, right? So now we're going to graph y equals 2 to the negative x minus 3. Now, one thing I want you to remember is that we had a horizontal asymptote at y equals 0. So the -3 is going to move our horizontal asymptote to -3. So we're going to go down right here. So that's going to be y equals -3. And all our points are shifted down 3 spaces. So this point's now going to be here. This point's now going to be here. And this point's now going to be here. And this should be our graph. Okay. So this would be reflect with respect to y-axis. And then shift down 3. And that's it. That's basically it. All right, guys. We do have to define the letter E before we're done. So let me go ahead and go over what that means. Okay, and then we'll do one real quick example, okay? So in math, we have this fancy number E. It's defined by this equation right here. You don't really have to remember anything, but you got to remember that E is equal to this. All right, it's 2.71828182828, and it keeps going. It's an irrational number. That's what E is, okay? It's kind of like pi. And it has special properties. We'll go over all of those when we do solving logarithms and stuff. So don't worry too much about this, but we are going to do some problems like that. And basically we're going to graph, okay? We got to, I mean, erase this. This is from class, my bad. Okay, and then, oops. And then, we'll get started, okay? So we're going to graph y equals e to the x, negative x. Why wouldn't it write? Okay. We're going to start with graphing y equals e to the x. If you remember the base, you should have the point 0, 1. Because e is approximately 2.71828. It's close when you at 1, you're going to be closer to 3 than you are to 2. So this is 1 comma e. And you're going to have the point right here, negative 1 comma 1 over e. Okay. And then you're just going to connect the graph like that. Okay. Then you're going to want to do, you see this negative on the outside? That's going to reflect across the y-axis. So now we're going to graph y equals negative e to the x, right? So that's going to shift our graph. So instead of having 0, 1, you're going to have 0, negative 1. Instead of 0, 1 comma e, you're going to have 1 comma negative e. And then you're going to have this point right here, which is negative 1 comma negative 1 over e. And then you're just going to connect the dots. Okay. So reflect with respect to the x-axis. Right. Last but not least, we have y equals negative x e to the x minus 3. This is going to go to the right 3, right? So we're going to copy our graph. We're going to go, instead of having it at 0, negative 1, we're going to have it at 1, 2, at 3, negative 1. And then you're going to have 2 comma 1 over e, negative 1 over e. And you're going to have 4 comma negative e. And that's what your graph should look like. Okay. And that's basically it, guys. E is just another number. It's kind of like pi. Don't worry about it. We're going to practice this in class tomorrow. So, have a great day. Hopefully this video wasn't too long. Bye-bye. How do I close this? End meeting.